Section 1.3, Solving Linear Equations. An equation is a statement that two expressions are equal. So we were dealing with expressions and simplifying expressions yesterday, and now we're going to be putting an equal sign between them, and we'll come up with an equation. A linear equation, and we're going to be dealing with linear equations at this point in just one variable, can be written as ax plus b equals 0. And in this case, a cannot be equal to 0, because if a were equal to 0, we wouldn't have a variable expression. We're going to be solving linear equations to find the solution. And a solution is a number that, when substituted in for the variable in the original equation, makes that statement or equation true. The property of equality states that if you add, subtract, multiply, or divide each side of an equation by the same value, you will maintain the equality, keeping in mind that you can't divide by 0. So for example, we can all agree that 2 plus 3 equals 5. The property of equality states that I could add 6 to one side. As long as I add 6 to the other side, I've maintained the equality. I can continue this. I could multiply both sides by 3, and I maintain the equality. So no matter what you do, as long as you do it to both sides of the equation, you're going to maintain the equality. Hopefully solving equations is going to be somewhat of a review, so we have just a few examples to go through, and then we'll be done. So our first example, 2/3 x minus 7 equals 5. Remember that when we're solving equations, the goal is to get the x, or the variable, by itself. So basically we're going to undo the order of operations. And so when we're undoing the order of operations, you need to remember that you're going to be undoing them backwards. So the first thing we need to do is undo any addition or subtraction. We're subtracting 7, so we're going to undo this by adding 7. And again, I'm demonstrating this for two reasons. So you refresh your memory on how to solve equations, but also so that you know at this point how I want to see you to show your work. So when we add 7 to both sides, we get 2/3 x equals 12. Now we're multiplying x by 2/3. So in order to undo multiplication, we would divide. We can divide by 2/3, but if you don't happen to have your handy-dandy calculator there, remember that dividing by a fraction is the same thing as multiplying by the reciprocal. So we could get rid of this 2/3 by multiplying both sides by 3/2. 3 on top cancels with the 3 on the bottom, and the 2's cancel. So we're left with x equals, and then 12 times 3/2 is going to give us 18. If we were to take this 18 and substitute it back up into my original equation, you'll see that 2/3 times 18 minus 7 should equal 5. 2/3 times 18 is going to be 9. It's going to be 12. Minus 7 equals 5. And we see that that is in fact true. Problem number 2. Your total cost for a book, including 6% sales tax, is $23.32. What was the price of the book before the sales tax was added? So again, remember that we need to define our variable. And you're going to define your variable by the question that's asked in the problem. So the problem wants to know the price of the book. So we're going to let x equal the price of the book. So in order to buy the book, we have to pay for the book plus the tax. Well, how do we find the sales tax that we would have? Well, 6% is the same as 0.06, and we're taking 6% of the price of the book. So the price of the book plus the tax has to equal $23.32. And now we need to solve this equation. Combining our like terms, we get 1.06x equals 23.32. And then we're going to divide both sides. Because we're multiplying x by 1.06, we're going to divide by 1.06 to undo that multiplication. And when you pop this into your handy-dandy calculator, you're going to get that x equals 22. Again, remember that it is a word problem. It's asking for the price of the book, so the appropriate label would be a $sign. The book was $22 before sales tax. Again, a relatively straightforward equation to solve. So what we need to do is we need to get all the variables to one side and all the numbers to the other side. So how do we do that? Well, we have a positive 13y. So in order to move the 13y over, we can subtract 13y from both sides. Again, I'm demonstrating how I would like you to show your work when I'm collecting your work, or especially on a quiz or a test. So 8y minus 13y is a negative 5y. On this side we still have minus 16, and on this side it's going to equal 9. Now we need to get our 16 over to the other side. Since we're subtracting 16 from that 5y, we need to undo subtracting, so we're going to add 16 to both sides, and we're going to show that we're adding 16 to both sides. So then I get negative 5y. 9 plus 16 is 25. And our final step, we're multiplying y by negative 5. So to undo multiplication, we're going to divide both sides by negative 5. And we find that y equals negative 5. In this problem, the first thing we need to do is we need to simplify each side. So we need to get rid of the parentheses and combine like terms. On the left, when we distribute our 4, we're going to get 8x minus 36. The 5x isn't in the parentheses, so we're just going to still have just that 5x. And again, on this side, when we distribute negative 3, we get negative 30. And then negative 3 times the negative x is plus 3x. Combining like terms on the left-hand side, 8x plus 5x is 13x minus 36 equals negative 30 plus 3x. Getting all the x's to the same side, we're adding 3x, so we're going to undo that by subtracting 3x from both sides. So we get 10x minus 36 equals negative 30. And then again, undoing the subtraction of the 36, we're going to add 36 to both sides. So we get 10x equals negative 30 plus 6. 36 is 6. And now divide by 10. We get x equals 6/10, but 6/10 simplifies to 3/5. So x equals 3/5. We can check our answer simply by taking this 3/5 and substituting it in for every x and simplifying both sides of the equation. And you would see that it would indeed work. It takes you 45 minutes to mow the lawn, and it takes your brother 30 minutes to mow the lawn. How long would it take you to mow it together? So basically we have the rate times time that it takes you, plus the rate times the time that it takes your brother, and that's going to equal one whole lawn. One job done. So your rate. So now let's think about this. It takes you 45 minutes to mow the lawn. So in other words, how much of the lawn can you get done in 1 minute? You can get done 1/45 of the lawn in 1 minute. If your brother takes 30 minutes, how much can he get done in 1 minute? He can get 1/30 of the lawn done in a minute. And we need to know the time that it's going to take you together, because you're working on this together. So this is going to equal 1. And that's our equation to solve. What I would do is multiply through by the least common denominator, because I personally don't like dealing with fractions. And the smallest number that 45 and 30 both go into is 90. So if I multiply 90 by 1/45, I'm going to get 2t, plus 90 times 1/30, I'm going to get 3t, equals, don't forget to multiply the whole equation. 90 times 1 is 90. This is a fairly simple equation to solve. 2t plus 3t is 5t, equals 90. Dividing both sides by the 5. and I get that t equals 18. Now again, we need a label. We're talking about minutes up in the problem, so therefore together it would take 18 minutes if you and your brother worked together. You need to make sure when you're doing word problems that your answer makes sense. It wouldn't make sense if we came up with a number that was bigger than 45 or 30. After all, you're working together. It should take you less time to get the lawn mowed together. Again, we need to distribute before we can get all the terms on the same side. So when we distribute, we're going to get 3x plus 15 equals 3x minus 12. Now perhaps you can see this right now, but in case you can't, let's just go ahead and try to get all our x's on the same side. If I subtract 3x, well 3x minus 3x is 0, so on this side I get 15 equals, 3x minus 3x is 0 over there, so I get negative 12. Does 15 equal negative 12? No. This is not true, and since this is not true, that means there is no solution. In other words, there is no value that you're ever going to be able to find to plug in for x that will ever make this equation true. And our last example. So we have 8x plus 12 equals 6x plus 12 plus 2x. Combining our like terms on the right-hand side, 6x plus 2x equals 8x. And you'll see that 8x plus 12 equals 8x plus 12. In this case, it doesn't matter what we substitute in for x, this equation will always be true. So the solution for x is all real numbers. You can abbreviate this, all real numbers, with a double-barred R. This means all real numbers. And that concludes the notes for section 1.3. Remember to go back to my website and fill out the form for today's notes. And please make sure you come to class with any questions, especially if you don't understand example 5 with those rates.